Hi friends, I am Mr. V. Venkatram Reddy, working as an assistant professor in an engineering college. I am starting a YouTube VV Reddy Mechanical Engineering, which gives the basics of all the mechanical engineering subjects. Today I am going to explain about simple strains. Here now I am going to explain about stress. Stress, it is a resistance force applied by a body against the deformation. Now I am considering here an object which is experienced by two forces P on each side. So here there is a stress induced at the middle of the block. So P is, let us say P is the load or force, A is the area of cross section. So now due to this force or load acting on that body, there is a resistance force offered which is opposite to the load or force. So that resistance force we are going to call it as stress, that is denoted by sigma. So here P is the load, it may be acting opposite to the resistance force. So here A is the cross sectional area, it may be depends upon the type of material. So sigma is equal to load by area. It is the ratio of load by area. So the units for the stress are: P is force, always in newtons; A is area of cross section, it is meter square or millimeter square. When the dimension is meter, it may be millimeters. So now it is the units for sigma stress is newton per meter square. Now we are going to discuss about the types of stresses. Mainly we have three types of stresses are there: tensile stress, compressive stress and shear stress. Now the tensile stress. So it is a stress acting on the body when the force is acting, that leads to increase the length of the block. Let us say here I am considering an object which is experienced by two forces P on either direction opposite to each other. Due to these forces, the length of the block or object increases. Due to this load, the length of the block or object will be increases. So in this case there is a deformation. Due to that there is a resistance force offered by a body which against for the load. So here in this case the induced resistance force is called tensile stress. So only the difference is whenever you are applied a load on this, it leads to increase the length of the object. Okay, so increase the length of the member when force is applied, that is called tensile stress. So the formula for this also: sigma is equal to P by A, load by area. So here only consideration is increasing length increases. So next, the second one is the compressive stress. So here in this case whenever the load is applied on a body, so the length of the member will be decreases. Compressed, the member will be compressed. Due to that compression, the length will be decreases. So in this case there is a resistance force offered by the body which is against the deformation. So in this case the induced resistance force is called compressive stress. So due to this the length will be decreases. Due to this compressive force the length will be decreases. So in this case length will be decreases. In this case sigma is equal to always P by A, where P is equal to applied load, A is the cross sectional area. So only the thing is in the compressive stress the decreasing length of the member when force is applied, right? So here also sigma is equal to load by area. Units are newton per meter square or newton per mm square. Next type is shear stress. So the shear stress is always acting along tangent of or along tangential direction of the member or an object. So now consider I am an object as shown in the figure. So here it is an object which is resting on a body, so on a ground. So here it is experienced by a force on top surface of the body or over the body, that means complete body. So here is the L is the length of the body, and and also L is the height of the body. So L by L is the dimensions of the body. So here, due to the force P acting on the body along tangent, so the top surface will elongate along the direction of tangent, along the direction of applied load. So due to that, in between the surface of top, there is a resistance force offered. So that resistance will leads to slide the body. Okay, so that slided force or slided the resistance force is called, you can say it is a shear force. Shear force is always acting over the surface of the along tangential direction. Due to this, there is a change of length dl. So here so here the shear stress is denoted by tau. So here the change of length along tangents is dl. So that is along the face of the member or face of the block. So here always the tangential force is acting along the face of the block. So due to that, there is a resistance force acting. So here the resistance force acting against deformation opposite to the applied load is called, so we can say it is a shear force or shear stress, we can say it is. The resistance along x-axis is called shear stress. X-axis is called shear stress. So shear stress tau is equal to applied load by area, P by A. Okay, P is always load. A you can say it is a dl into L because along tangent direction. Next one is the strain. Strain is always we can define as ratio of change in length to original length. Whenever there is a stress induced in a body, it may be tensile, compressive or shear stress. Due to that, there is a change of length. Okay, so it may be millimeters or centimeters or meters. So whatever the percentage of change in length, we can take it is a change in length. So that ratio is called strain, we can say it is. So always it is the ratio of change in length to original length. So epsilon is equal to dl by L, we can say it is. It is having no limits. Okay, so this is about today's topic. Now I am discussed about simple stress, types of stress and strain. So in the similar way, strains also we can say it is three types: tensile strain, compressive strain and shear strain. Based on the applied force and based on the induced stress type of stress, we can say it is a type of strain. So thank you for watching my video, and please subscribe to my channel, so and encourage me to upload more videos which is helps to you basics and write the exam the toughest subjects like mechanics of solid